So velocity of sound in a gas is given by V is equal to under root gamma P by O. Isn't it? This is the formula, corrected by Laplace. Now if you observe this formula, velocity of sound कशावर डिपेंड आहे असं वाटतं आपल्याला? प्रेशरवर. म्हणजे प्रेशर वाढलं तर वेलॉसिटी वाढेल, प्रेशर कमी झालं तर वेलॉसिटी कमी होईल. बट इट इज नॉट लाईक दॅट. तसं नाहीये. प्रेशर हॅज नो इफेक्ट ऑन द वेलॉसिटी ऑफ साऊंड इन अ गॅस. व्हॉट कॅन बी द रिझन? काय कारण असू शकतं? Because it not only depends upon P, it also depends upon rho. If the pressure increases, the molecules of the gas will come close, means its density will also increase. So if pressure increases, the density also increases, means the ratio remains constant there. And to be more scientific, we can say that according to ideal gas equation, PV is equal to nRT, isn't it? PV is equal to nRT, that is ideal gas equation. For 1 mole of a gas, PV is equal to RT. For 1 mole of a gas, PV is equal to RT. So in place of P, we can write RT by V, correct? Or in place of PV, we can write RT. So the formula for velocity of sound in air, gamma P by rho. This formula will be modified now. This is equal to under root gamma P by rho. Rho means what? Density of the gas or density of air, and density is mass upon volume. So in place of rho, we can write mass upon volume. So velocity of sound in a gas becomes under root gamma PV by M. In place of PV, for 1 mole, we can write RT. So velocity of sound in air will be under root gamma RT by small m will be replaced by capital M. Very important. Small m means काय आहे? Mass. And capital M is molecular weight. Why we have replaced small m by capital M? You have studied this in mole concept in chemistry. Mass of 1 mole of a gas is equal to its molecular weight. Gas च्या 1 mole चा mass किती असतो? Equal to its molecular weight. We have taken 1 mole of a gas. So mass of 1 mole is equal to its molecular weight. So we got V is equal to under root gamma RT by capital M. It is gamma PV by small m, or it is equal to gamma RT by capital M, right? So this is the velocity of sound in air. V is equal to under root gamma RT by M. So according to the corrected formula, velocity of sound in a gas is under root gamma P by rho, or it is equal to under root gamma PV by M, mass of the gas, or it is equal to under root gamma RT by capital M. Now PV is equal to RT for 1 mole. We have used it here. If temperature is constant, from this formula, if temperature is constant, PV is constant. कारण R तर constant आहेच आहे. R म्हणजे काय आहे? Universal gas constant. What is R? Universal gas constant. तर temperature जर constant असेल, तर आर तर कॉन्स्टंट आहेच आहे, म्हणजे दोन्ही कॉन्स्टंट आहेत, मीन्स पीव्ही इज कॉन्स्टंट. So if temperature of a gas is constant, PV is constant. So look at this formula. If temperature is constant, PV is constant, gamma तर constant आहेच आहे, mass is also constant, means velocity of the gas will remain constant. The temperature constant rahila, तर velocity of the gas remains constant. There is no effect of pressure, because if temperature is constant, PV is constant. Therefore, there is no effect of pressure on the velocity of sound in air. So, which factors affect the velocity of sound in air or velocity of sound in a gas? Number one, there is no effect of pressure on the velocity of sound in a gas. प्रेशरचा काहीच इफेक्ट होत नाही. तर v इक्वल टू अंडर रूट गॅमा पी बाय रो आहे, v इक्वल टू अंडर रूट गॅमा पी व्ही बाय एम आहे, आणि पीव्ही कॉन्स्टंट राहतो. जर टेम्परेचर कॉन्स्टंट राहिला तर म्हणजे वेलॉसिटी चेंज होत नाही. नो इफेक्ट ऑफ प्रेशर ऑन द वेलॉसिटी ऑफ साउंड इन एअर. अँड third formula is V is equal to under root gamma RT by M. V is equal to under root gamma RT by M. That is velocity of sound in a gas. What is this gamma? Gamma is ratio of specific heats, which is a constant. R is universal gas constant. Capital M is molecular weight of the gas, that is also constant. म्हणजे हे तिन्ही कॉन्स्टंट आहेत, मीन्स V proportional to काय होईल, under root T. So that is the effect of temperature on the velocity of sound in gas or velocity of sound in air. Velocity of sound in a gas is directly proportional to square root of its absolute temperature. कोणताही टेम्परेचर घ्यायचा नाही. कॅपिटल टी चा अर्थ काय आहे, ऍब्सोल्यूट टेम्परेचर, टेम्परेचर इन केल्विन. सो velocity of sound in a gas is directly proportional to square root of its absolute temperature. That is the effect of temperature on the velocity of sound in a gas. So number one, there is no effect of pressure on the velocity of sound in a gas if temperature remains constant. And number two, velocity of sound in a gas is directly proportional to square root of its absolute temperature. So, if you consider the velocity of sound at two different temperatures, suppose velocity at 0 degrees Celsius, velocity of sound in air, suppose at 0 degrees Celsius, त्याला म्हणूया V0, and velocity of sound at a temperature T, T degrees Celsius वरची velocity, that is Vt. V0 is velocity of sound in air at 0 degrees Celsius. Vt is velocity of sound in air at T degrees Celsius. Then from this formula, Vt upon V0 will be equal to what? Absolute temperature at T degrees Celsius upon absolute temperature at 0 degrees Celsius. Under root absolute temperature at T degrees Celsius असणार 273 plus T है ना. absolute temperature कसा काढतो आपण, टेम्परेचर डिग्री सेल्सियस मध्ये हे ऍड करतो. सो T plus 273 or 273 plus T upon absolute temperature at 0 degrees Celsius. How much it is? 273 Kelvin. So Vt upon V0 is equal to under root 273 plus T upon 273, or this can be written as under root, if you split it, 273 upon 273 is 1 plus T upon 273. So from here, Vt upon V0, Vt upon V0 is equal to under root 1 plus T upon 273. Got it clear? I'll rub this. What is this Vt? Velocity of sound at t degrees Celsius, velocity of sound at 0 degrees Celsius, and T is the temperature T. Okay. Now, this T upon 273, if you call it suppose X, T upon 273 ला आपण काय म्हटलं X, then Vt upon V0 will be equal to under root 1 plus X. Correct? Vt upon V0 is under root 1 plus X. Or you can say Vt is equal to V0 या बाजूला गेलं. Under root 1 plus X means 1 plus X raised to half. So Vt is equal to V0. Under root 1 plus X means 1 plus X raised to half, whereas X is T upon 273. आता जर आपण T टेम्परेचर स्मॉल टेम्परेचर जर घेतला, कारण ऍटमॉस्फेरिक टेम्परेचर कितीने चेंज होणार? 1 डिग्री, 2 डिग्री, 10 डिग्री, 20 डिग्री, 273 डिग्रीने चेंज होणार का ते? नाही. मीन्स T अपॉन 273 इज व्हेरी स्मॉल, कारण T 10 असू शकतो, 20 असू शकतो, 30 असू शकतो. तर T अपॉन 273 म्हणजेच X is very, very small. So in this formula, X is very, very small because X is T upon 273. So change in temperature 10, 20, 30 upon 273 is very small. So in this formula, X is very small. So using binomial theorem here, you remember what is binomial theorem? Binomial theorem says that 1 plus x raised to n, आपण हे आधी केलेला आहे 11वीला, 1 plus x raised to n is equal to 1 plus nx, 1 plus nx plus terms having high powers of x. 1 plus x raised to n is 1 plus nx plus terms having high powers of x. And if x is very small, terms having high powers of x can be neglected. कारण x जर small असेल तर त्याचा square आणखीन small होणार, x cube आणखीन small होईल. Terms having high powers of x can be neglected. So if x is very small, 1 plus x raised to n is equal to how much? 1 plus nx according to binomial theorem. So this equation will now become, because x is very small, Vt will be equal to V0 into bracket 1 plus half x, 1 plus nx, 1 plus half x. So Vt is equal to V0 into bracket 1 plus half x. Or you can say Vt is equal to, bracket जर ओपन केला आपण, V0 plus V0 into x by 2, bracket ओपन केलाय, that is equal to V0 plus V0 into x किती आहे? T upon 273, T upon 273 into काय आहे? 2. So Vt will be equal to V0 plus 273 into 2 is 546. हे किती आहे? 546. आणि V0 म्हणजे काय आहे? Velocity of sound at 0 degrees Celsius at NTP, which is equal to 332. So put those values here. It will become V0 plus V0 च्या जागी 332 into T upon 546. याला जर कॅल्क्युलेट केलं 332 upon 546 तर ते येतं 0.61. किती येतं ते कॅल्क्युलेट करा. It is 0.61. Therefore Vt is equal to V0 plus 0.61 T. That is the formula for velocity at T degree Celsius. Vt is equal to V0 plus 0.61 T, whereas V0 is velocity of sound at 0 degrees Celsius and T is the temperature. This formula means that for every 1 degree rise in temperature, atmospheric temperature जर 1 degree Celsius ने वाढलं, for every 1 degree rise in temperature, the velocity of sound will increase by this much. एवढ्याने काय will velocity of sound वाढेल. That is the effect of temperature on velocity of sound in air or in any gas. Again, V equal to आहे under root gamma P by rho. There is no effect of pressure. Gamma is constant, means V is proportional to 1 upon under root rho. Means V is inversely proportional to square root of density of the gas or density of air, whatever it is. V is inversely proportional to square root of density of the gas. Now, if you consider air, the density of dry air is more and density of wet air, moist air is less. Say, density of dry air is more, density of moist air is less. So velocity of sound in dry air upon velocity of sound in moist air will be equal to under root rho m upon rho d. Inverse proportion आहे, तर d च्या समोर m आणि m च्या समोर d, means density of moist air upon density of dry air. So velocity of sound is inversely proportional to root rho. Density जास्त असेल तर velocity कमी असणार, density कमी असेल तर velocity जास्त असणार. Density कुणाची जास्त आहे? Dry air ची. So density of dry air is more, so velocity of sound in dry air will be less, and density of moist air is more. Right? Sorry, ulta bollo mi. Density of dry air it is more, and density of moist air is less. Okay, density of dry air is more, and density of dry air is moist air is less. So dry air ची density जास्त असल्यामुळे त्याच्यात velocity कमी असणार. Moist air ची density कमी असल्यामुळे त्याच्यात velocity जास्त असणार. Means velocity of sound in moist air is more than the velocity of sound in dry air. That is the effect of humidity on the velocity of sound in air. So these are the factors affecting the velocity of sound: effect of pressure, effect of temperature, and effect of humidity. Humidity म्हणजे काय? आर्द्रता, moisture content in air. तर density कुठे जास्त असते? Density of dry air is more, density of moist air is less. On my number. Rest of the things we shall see in the next lecture. Have a nice time. Good night. Bye-bye.